Okay, guys, in this lesson, we're going to learn how to write a linear system, a system of linear equations from word problems. We will either write them in slope intercept or we will write them in standard form. So remember, slope intercept form is y equals mx plus b, where we know our rate of change and our starting point, our y-intercept, or standard form ax plus by equals c. Once we write these in one of these forms, we will either use substitution or the elimination method to solve. Let's take a look at our first example. Haley bought 2 new candles. Her first candle measures 16 centimeters and burns at a rate of 1/4 centimeters per hour. Her second candle measures 22 centimeters and burns at a rate of 1/2 centimeters per hour. We are asked to find out at what hour would the candles be the same height, and what will that height be? So let's represent the total height, which will be y, for candle 1. So candle 1 is going to start out at 16 centimeters. It's going to decrease in height, burn at a rate of 1/4 per hour. So x will represent hours. Candle 2's total height starts out at 22 centimeters high, and it burns at a rate of 1/2 centimeters per hour. So again, x is hours and y is total height. Since we have isolated variables, I'm going to choose to use the substitution method. I am going to take negative 1/4 x plus 16, what y equals, and substitute it in for y into candle 2 equation. So I have negative 1/4 x plus 16 equals negative 1/2 x plus 22. Now, I'm going to go ahead and apply that mathematical practice of getting rid of my fractions by multiplying the entire equation by the least common multiple, which is going to be 4. So I'm going to multiply everything by 4. And this gives me negative 1x. And then 4 times 16 is 64 equals. And then when I multiply 4 times negative 1/2, 1/2 of 4 is 2, and it was negative. And then 4 times 22 is 88. Now I have integers across the board. I have a negative 1x and a negative 2x. Negative 2x is smaller, so I always like to get rid of my smallest variable because that gives me a positive coefficient. So I have x plus 64 equals 88. I'm going to subtract out my 64, and x, which is hours, is going to be 24. So at 24 hours, we can get the total height. Now we can use either equation we want. I'm just going to use this first one. So I'm going to plug in 24 for x, y equals negative 1/4, plug in 24 for x plus 16. So y equals, I have a unit fraction. That means my numerator is 1. That simply means I can divide my denominator into my integer here. So 4 into 24 is 6, and it's negative, and then plus 16. So my total height is going to be 10 centimeters. So this is 24 hours, and this is height, centimeters. Okay, let's take a look at another example. Josh needs to take his truck to the shop. The first mechanic charges a flat rate of $75 for a diagnostic check and $30 per hour to service the truck. Mechanic 2 charges $100 for a diagnostic test, and that's misspelled right here, so let's just fix that right there, and $20 per hour to fix the truck. So let's read this again. Mechanic 1 charges a flat rate of $75 plus $30 per hour. Mechanic 2 charges a flat rate of $100 plus $20 per hour to fix the truck. We want to know at what hour would either mechanic 1 or 2, will charge the same amount, and what will that charge be? So we're going to have y equals, y is going to represent the total amount charged to work on the truck. So mechanic 1 charges $75 up front. And then in addition to that is $30 per hour. So X again will be hour. Mechanic 2 is going to charge a total amount of the $100 upfront fee, the flat rate for the test, plus $20 each hour he or she works on it. We are asked at what hour will they charge the same? We want to know when mechanic 1 equals mechanic 2. So I'm going to use substitution. I'm going to plug in what Y equals for mechanic 1 and plug it in for mechanic 2. So I'm going to replace Y with 30x plus 75 equals 20x plus 100. I have variables on both sides. I'm going to subtract out my smaller variable term. And we get 10x equals 25. Now we're going to divide by 10, and x, which is hours, is going to be 2.5. So at 2.5 hours, both mechanics charge the same amount. Now let's take that x value and we can plug it into either equation. I'm just going to plug it into the second one. So y equals 20 times 2.5 plus 100. So we have 2.5 times 20. And then we have to add the 100. So y is going to be $150. So 2.5 was our hours, and 150 was the total charge. Jude's piggy bank consists of quarters, quarters and nickels. There are 43 coins that have a value of $5.55. How many of each coin does he have in his bank? So I really have no constant rate of change here. So I'm going to use standard form. So if I have not given a rate of change, that kind of lets me know that slope-intercept form may not be the best choice. Okay. So let's talk about the two different equations we can create, because remember a system works with two or more equations, and that's what lets us figure out the solution. So I can break this down into two equations. I can represent how many coins I have and how much in value of the coins I have, because I have those two totals. I have a total of coins and a total value. Now I'm going to use variables that help me know what each part I'm representing. So I'm going to say that I have so many quarters plus so many nickels equals a total of 43 coins in all. You will have to excuse the pauses. My little puppies are being a little naughty. Okay, now we need to represent the value of the coins because I have a total value. So the value of a quarter is 0.25. So I have 25 cents per quarter, plus Jude has a total value of 5 cents per nickel, and altogether he has a value of $5.55. So I have the number of coins and the value of the coins, and that's the two equations that are going to work together as a system to let me know how many of each coin that he has. Now, just like we got rid of our fractions earlier, we can also, quote unquote, get rid of our decimals by multiplying by a power of 10. Every time we multiply by a power of 10, it moves our decimal over to the right. So I am going to get rid of these decimals because I'd rather work with integers by multiplying by 100. If I multiply by 10, it moves it. And if I multiply by 100, it moves it twice. So I'm going to multiply this equation by 100. And I get 25q plus 5. Forgot my n here. Let's go back and fix that. And then I have 5n equals 555. So now I'm working with this equation and this equation. Since they're in standard form, I am going to use elimination. So I could either make this q become negative 25 by multiplying through by negative 25, or we could multiply this equation by negative 5, and that way the nickels cancel out. And I usually like to use the smaller numbers, so I am going to multiply this equation by negative 5. So I'm going to get negative 5q minus 5n equals negative, and we're going to multiply 43 times 5. That gives us negative 215. And now when we combine these equations together, we are going to have eliminated the n's. And so this gives me 20q equals, and we subtract these out, that looks like 340. And then we divide by 20. And the number of quarters, 34 divided by 2, looks like it is 17. So Jude has 17 quarters. And since I could take 17 and plug it into this equation, but it's much easier here because we have 43 coins in all, and 17 of those are quarters. So I can just simply subtract 43 minus the 17 quarters, and I get 26 nickels. And we could check this by multiplying 17 by 0.25 plus 26 by 0.05, and we should get $5.55. The 8th grade students from Creek Middle School and River Middle School are going on a field trip. Creek Middle takes 4 buses and 6 vans with a total of 272 students. River Middle uses 5 buses and 3 vans with a total of 241 students. How many students ride in each bus and in each van? So again, I don't really have a rate of change here, so I'm going to use standard form. So let's represent Creek Middle. So we have 4 buses plus 6 vans, and we have a total of 272 students. For River Middle, we have 5 buses plus 3 vans for a total of 241 students. So I have written these in standard form. Now we do not have a pair of opposites, but we could easily make this 3v into negative 6v. So the v's, the vans, would be eliminated. So I'm going to use the elimination method, and I'm going to multiply by negative 2. So we get negative 10b minus 6v equals negative, that's going to be 482. I'm going to just bring down this equation, and we're going to combine these using elimination. So negative 10b plus 4b is negative 6b. My v variables are eliminated, and then I get negative 200 and looks like 10. We're going to divide by negative 6. and see how many students ride on the bus. That's going to be 35. So we have 35 students on a bus. Let's see how many students ride per van. I'm just going to take this second equation. It doesn't really matter. Either one will work. So I'm going to take 5 and then multiply by 35 plus 3v equals 241. We have 5 times 35. That's 175. Plus 3 times v equals 241. Subtract out our 175. That gives us 66. And then when we divide by 3, the number of students per van is 22. 22 students per van and 35 students per bus. The NFMS Band sold 18 adult tickets and 28 student tickets on the first day of ticket sales. The total collected was $312. On the second day, the band sold 28 adult tickets and 14 student tickets. On this day, they collected $308. Determine the price of each ticket. So let's represent day 1. So we don't really have a rate of change that's given to us directly. So we're going to have 18 adult tickets plus 28 student tickets. And be careful when you use an S for a variable that you don't think of it as a 5 when you're working, equals a total of 312. Then we have 20 on day 2, we sold 28 adult tickets at some price plus 14 student tickets for a total of $308. So I've written these in standard form so that I'm going to use the elimination. So we can see that we do not have a pair of opposites, but luckily for us, we could simply multiply this equation by -2, making this a -28s. So let's do that. So we have 28 times -2 gives us -56 minus the 28s that we were wanting equals -616. I'm going to bring down this equation and write it underneath my new day 2 equation, and we're going to combine. And because I use these specific variables at the end when I'm solving, I know which value that represents. So we're going to combine these. I have 38a. My s's are eliminated. Get equals -3, and this should be a -38 here. This is -304. So I have -38a equals -304. Let's divide by our -38 to see the price of adult tickets. And that's going to be $8. So an adult ticket is $8. And then we need to find the student price. So we're going to take this 8 and we can plug it into any equation. I'll just plug it into our first one. So we have 18 times the price of an adult ticket plus 28 times S equals 312. So 18 times 8 is 144 plus 28, that's an S, equals 312. Let's subtract out 144. and we get 168. We're going to divide by 28 on both sides. Sorry about that. And we get $6. So student tickets are $6. Okay, here's our last example. A charity is considering the possibility of having a benefit night at 2 different restaurants. The owner of the local Italian restaurant has offered to donate $836 and $4 per dinner that night. On the other hand, the owner of the Mexican restaurant has said he could contribute $340 plus $5 per dinner. Based on the number of dinners who have promised to participate in the event, it appears that each restaurant would donate the same total amount. How many dinners promised to participate, and how much would each restaurant donate? So we're going to represent the Italian restaurant is going to give $836 up front, then $4 per dinner that night. So Y will be the total donation for each of these, and our X will be the dinners sold per night. So here we have our equations. I am going to use substitution. You could use elimination if you wanted and multiply through. We could multiply and get rid of our y's simply by multiplying by -1 on each equation and eliminate those y's and solve for x. I'm just going to go ahead and use substitution. So I'm going to substitute in what y equals here into the y for the Mexican restaurant. So we have 4x plus 836 is equal to 5x plus 340. I have variables on both sides. I'm going to subtract out the 4x. So I have positive coefficients. We have a 1x, which is nice. And now I simply have to subtract out the 340 to see how many dinners to be sold. So this is going to be 6. That will be 496 equals x. So that's the number of dinners sold. And then we could plug this in to see how much total amount each restaurant will contribute. So they're contributing each an upfront amount. In addition to that, they're going to contribute how many dinners are sold. So I'm going to plug in just my first equation, y equals 496 plus the 836 to see the total amount raised. So let's grab our handy dandy calculator. 4 times 496 gives us 1,984 plus the 836, and that gives a total of 2,820. So with 496 dinners sold, each will have contributed $2,820. So this is dinners, and this is total amount.